Good afternoon, everybody. So I'm going to talk about data architectures and analysing XBRL data. And I'm not going to focus on long-term trend analysis or benchmarking. I'm going to focus on helping operational decisions. And the reason is because I'm not going to do a deep tech dive of databases or anything like that. So you don't need to head to the door. But I think this is a good use case that brings together all the kind of issues we've been talking about the last few days, and also helping us decide where to push the XBRL standards over the next few years. It's one of those things that come up in all the requirements of regulators across Europe. And it kind of brings together many of the issues that have been discussed over the last 2 days. So, my kind of pathway for taking you through this, and I have to build up the case, is I'm going to talk about operational data stores and their role within an XBRL collection system. And I'm then going to talk a little bit about how you would deliver one of those today. And then, hopefully, you'll begin to understand some of the issues that the unique structure of XBRL causes. And then I'm going to take a kind of little sidestep. I'm going to quickly explore what's going on in the world outside, because there is a world outside this little community, I'm afraid, and it's doing lots of wonderful things in the data area. And at the end, I'm going to talk about what this really means for the XBRL standard, and the clue is already there. It's in OIM. So, let's start with an architecture slide. So this is Gartner's logical data warehouse. You know, these have been were used glibly up to about 2020. And maybe we can have a quick game of Where's Wally and somebody find ODS? No? And nobody play the game Where Wally with their kids? No? Okay. It's there. So the ODS, the Operational Data Store, is the first storage of transactions in one of these models. I don't know what this bit on blue on the left of it is, and it's kind of mixed in with master data management, which again is another good link to XBRL. The funny thing is, I put this slide together, and then I realized that actually it's got XBRL there. So Gartner also appreciates that XBRL is one of those formats that will be part of this logical data warehouse. So, let's simplify that, because let's break it down. It's much easier to understand that we take transactions, we put them into an operational data store, and that's where we kind of make operational decision making about whether we have high quality data, the right data, are the entities actually reporting the way we want? And before it gets pushed on to the data warehouse structures or to the analysis side. And the little loopback blue line is segmentation analysis. So we might decide that there's a certain group of entities that need further research or particular business performance ratios that we would like to see if they meet those particular ratios. So this is the typical ODS model. Now, let's put XBRL on top of that. So we deal with XBRL reports, which is a very strange transaction. Transactions are normally little short things. Of course, ours has a big model. It can range from hundreds of data items to hundreds of thousands of data items. So it's very, very unusual. Now, the ODS is about ensuring data quality. So there are always those outliers. There are always those documents that are filed where it raises warnings or it raises issues that need a check. And unfortunately, AI is not going to resolve that in the next few years. It's going to be manual. So we're going to check warnings. We have organizations like the ECB who add additional checks onto the data. So if they're looking at the European Banking Authority, there's lots and lots of modules, but we can only validate the one report. So what they do is they add cross taxonomy reports. They do these checks, extra checks. They're non-XBRL rules. We just can't implement them in XBRL. They also load benchmarking data. So they create banking performance ratios against which each of those segments they can check. So they can check if there are any outliers, and they can check if the data looks to be right. The last thing is ad hoc analysis. There's always something that's going on in the reporting framework that you want to be able to check, and you want to run a quick query on a segment of data, particular elements, particular issues. And this is all before it goes through to the analysis stage in the data warehouse. So this is where you do your trends, your benchmarking, and the obligatory AI, of course, because that's what we're talking a lot about this conference. So, you know, it's a very important role. And whatever we say, however much we improve the formulas, the rules, the definitions, we're always going to have some issues there in the middle. As I say, every regulator I've ever seen in Europe has those in its set of requirements of how to find those particular reports, how to identify what to do with them, and what way would we compare them against others. So, the ODS is a very, sorry, moving away from my mic. The ODS is a very simple way to look at the data in near real time. Now, I won't define real time because it kind of depends upon the system. You could kind of open up an SF report in an iXBRL viewer. You could have a look at it, and you'd probably open up a second one, maybe the year before, or a similar kind of organization. You could compare them. But a third, a fourth, a fifth, no. If you're looking at, say, solvency data in Europe, you take a table like SO6, it could have 100,000 rows. So you wouldn't want to use, you know, a kind of review of those in Excel or anything like that to be able to work out, you know, what's going on between that and another report, maybe the previous year's report. And so it's also difficult to enrich with other benchmark data when you're reading them as a kind of XBRL rendering. So you probably all know the answer. It's a database. A database will help us with the filtering, the comparison, all of those kind of things, running ad hoc queries. That's what a database does. But the question has always been, for the last 15 years or so that I've been working in XBRL, is which one? We started looking at XML. We worked with Oracle. We worked with IBM DB2. Materialized views in Oracle, if anybody knows it, was promising. But for Oracle, it was a minimal bit of revenue, and they just weren't interested in keeping up standards. We then turned to semantic databases because we keep the semantic relationships in our XBRL models. So that seemed an obvious place to go. The problem is you probably need to convert the data into something like JSON. Well, we've only just managed to resolve that. And you still need to parse the taxonomy, which is in XML. And that, there is no standard for that. So everybody would be working on their own custom parsing software. The skill sets for semantic databases are rare and kind of like specialized and niche. So when you add up the cost of all of these, it's just too expensive. So you're left with the good old trusted SQL database. And most of us understand it, most of us can work it and use it. However, you need a very unique structure to help you analyze XBRL data when it's in SQL. So let me again kind of show the problem so you kind of get the feel for this. When we get an XBRL document, we put it in the file system, we say, oh yeah, company A has submitted this document, we submit it with a taxonomy, it's really easy. We create a mapping table to shred the data into some sort of star schema or something else. Easy. The problem comes with next year's, when the model changes. And suddenly we have a new taxonomy, and we change labels, and we deprecate values, and we have to play around with the model. and suddenly it becomes an issue. And look at a typical NCA in Europe, a National Competent Authority, for those of you not familiar with the language. They've got EBA, CRD, which is, I don't know how many taxonomies now, but modules. You've got EOPA solvency, you've got pension funds, you've got investment management funds, you've got SF, you've got ESRS coming, and you've got local taxonomies. So think of trying to implement that kind of system for all of those kind of uses. It's okay if you've got one and the taxonomy doesn't change a lot, but if the taxonomy changes, that's when all the work starts. So it creates two independent systems, which is always a problem because the second one doesn't really keep the semantics, and it's also very high maintenance. So these are the kind of issues that all the vendors probably in this room have been playing with over the last X years. So the answer has been to try and find a standardized way of storing the XBRL taxonomy, of keeping that rich semantics that we invest in the taxonomy model, and then also finding a way of loading instance documents quickly, because it's no good waiting hours for an instance document to be loaded. So you typically end up with a very simple snowflake structure is the way to describe it. Don't really try and think about it, but a big, long, fact table with descriptions of the taxonomy in a kind of snowflake, and a description of the instance document, the entities, the time period they're reporting, those kind of things. So that's all well and good, but anybody who knows anything about databases, that is particularly difficult to write SQL for, unless you're an expert and you know the model. And so you also have to embed within that same system some way of a reporting architecture to get the data out. Yeah? And then you also want to build into that the fact that the ODS often serves the other parts of the data analysis, so the data warehousing, the data mesh, the data fabric, whatever you want to call it these days. So you want to be able to create these partitions easily and readily for onward communication. So here's a picture of one. This is the kind of structure that you end up with because of XBRL's unique format. We've got on this side, look at the big blue bit in the middle, that's the most important bit. So it's the base facts in the blue. You get an instance document, you register the taxonomy, you basically move all the link bases and all the relevant information into the blue tables. This is a very, 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 very simplified version of it. The instance document, you record the entity, you record the taxonomy it's for, you record the dates and all the relevant other data. And then you store the instance data, the XBRL facts, in the big fact table, the white table. It's very simple. And it's quite performant. That's the good thing about it. And everyone knows these kind of architectures who've worked in relation to databases. But we can't, as we said, extract the data easily. Complex SQL queries, are hard to write at the best of times. So we use this extractor, and the extractor lets us say things like, give me all the reports for this period, for this taxonomy, for all concepts. And it literally creates a cube of data. And when we create that cube of data, we basically flatten or iron out all the wrinkles in the XBRL. We basically combine it into one flat row that enables standard BI tools like Click, Power BI, whatever your particular tool is, so that you can query that data relatively easily. Yeah? You can also enrich the data as well with benchmarks, because most of these self-service BI tools have the capability to bring in other data and enrich this data. The other thing is you could pick out a kind of ad hoc cube, all the banks from this segment, and just this bits of data, and with these performance ratios. And you can begin to compare that. So this is the kind of structure we have to build today. And it works well. It even works for things like SF. You'd think SF, each with its own taxonomy, would cause it problems. But because most of it is built on the IFRS as its core taxonomy, you can use that to enhance the kind of queries that you would do in SF. Still got to do the extensions and carry those as well. But yeah, this kind of model works well. And the partitions for a period go into the data warehouse, the ad hocs, the kind of current stuff can be used for that operational decision making. Compare this year's with last year's, compare this report with other similar types of entities, query about this kind of issue that's been a reporting problem for a certain group of entities. And it works very well. And it's been implemented like this across Europe, and I'm sure other vendors have implemented similar kind of models. Now I'm going to step aside from XBRL and go outside the door here and kind of look at what's been happening in the kind of data world for the last 5 years or so. What we've seen is that the whole kind of way data warehouses have looked has gone through various stages. We had the data warehouse, it became the data lake. The data lake was then nicknamed the data swamp because we couldn't get the data out. So we went back to kind of data lake houses. We started looking at the data in kind of domain specific with data mesh and other ideas like data fabric. To be honest, they're all kind of the same. They're just trying to optimize the way you store the data. And the big thing here is kind of merging highly structured data with very unstructured data, which to all of us, we all kind of recognize because we've been talking about it for the last few days. Unfortunately, there's lots of legacy systems left lying around in corners of most enterprises as they kind of move between these different structures. But the real bit about this is the bit at the bottom. So the industry is going through a kind of revolution, and this revolution is driven by the move to the cloud. So in one of my earlier slides, I had ETL, extract, transform, and load. And the reason why we did transform kind of like in line was because we only had so much disk in our internal systems. And to replicate the whole data set again, and probably again, as a temporary set of files, why we did the transformation was very difficult. You're on the cloud. Effectively, you can buy disk as you go along. In fact, you've got limitless disk, really, when you think about it. And not only that, you're only paying for that disk for the time you're using it. And then you kill all those temporary files, and you have your transformation. So they're moving to this idea of extract, load the data, and then transform it, which is another idea. And there's all the big players, Azure, Google, BigQuery, AW, Redshift. I don't know if any of you guys recognize this stuff. Databricks, Snowflake, DBT. There's a whole list of packaged data warehouses. It's great. If you're in that kind of area, the job of a data engineer has never been so exciting. You even have zero ETL. So you could link an operational data store like Aurora in AWS and move it into Redshift. And they help you with all the tooling and the design of the data warehouse. Platforms for AI. I've got AI in there again twice for this specific for this show. But this isn't Gen AI, which lots of people are a bit confused about, to be honest, in my view. But this is machine learning. This is machine learning on very large data sets. And we are getting, in XBRL now, very large data sets. Not only historically, but also moving forward, we're getting more and more data. Oh yeah, and I'll just put this last one in because this is what is intriguing me at the moment. It's called Graph RAG. RAG is retrieval augmentation to help LMS models perform better. So you kind of teach them. So Ravathi and I were talking about this earlier. RAG is about teaching AI what a financial report is and what the difference is between a US financial report and, say, an SF report. And once you've taught it, it then improves its understanding, and it can use that to better interpret things. Graphs are really just a method of making communities of the different concepts, vectors, whatever you want to call them, can help. So this actually is one of the areas I think could help us, maybe. You never know. A lot of these kind of work and a lot of them don't. There's the problem at the bottom, though. We can't use any of it, not without a lot of work. So as an XBRL community, we're all sitting here going, yeah, we've got all this XBRL data. So can I use any of them? Not without a lot of work. Can't use the tools, can't use the design things. It's a real problem. So this is really my use case of where we should be heading XBRL standards in the future. We've already gone on this path of the open information model. I've hardly heard it spoken about, but I guess Paul and John will talk about it tomorrow, hopefully. It really is an important re-architecting of the standards. And it's therefore important, I don't want to appear like a recruiting sergeant, that people involve themselves and can comment on this and can add to it. We've already defined XBRL CSV and XBRL JSON. JSON for sure definitely helps with semantic databases and some of the AI tools that we need to do. It's simplifying the model. Many of you in here may not know that we have a big issue between using SF and using UK or US SEC taxonomies, because one defines something in scenario and the other one does it in segment. And I can never remember which way round it is, but it's an issue. We just can't resolve the two. Tuples, another example of an old-fashioned kind of structure that we can make simplify. So simplifying, giving more formats, re-architecting and getting involved. So we talked about the OIM taxonomy. This would help us greatly in terms of parsing taxonomies into semantic databases and into many of these other models that I put up earlier. OIM rules. So, we are in the process already about removing the XML paths from XPath out of the OIM rules and making them much more general. This should allow the vendors in this room to begin to optimize their processing of formulas. Yeah? That's a big move forward. It also means you can check the taxonomy, whereas we can't with the current formulas. So this will also be another one of my big milestones. When we achieve that, we will be moving XBRL forwards. And the last one, I'm going to scare Paul by saying, it's not just CSV and JSON, but we do need a form, and unfortunately this has been my kind of dream since I kind of joined the XBRL community all those years ago, is to be able to have it for databases. Somehow bring the structures of databases together with the semantics that we deliver, to put this semantic layer above databases and define the database structures below. Because that will be the door opener for all those kind of other models we've seen explode in the cloud over all these last few years. And that would open up our data, the kind of data that the regulators in this room collect, and all the filers have to spend so much effort tagging to other people in open data. It won't remove all the other issues associated with open data. We were having a conversation earlier about this, but it will make it much more technically feasible to be able to use this data. So, we started with ODS. We kind of ended with a pathway for where OEM should be going. Again, recruiting sergeant, but you should, if you're interested, get involved if you've got something to say. If you don't want the standard to be designed around you, get involved with the working groups and with XSB. Thank you.
Thank you very much. Thank you very much indeed. Okay. This is another great presentation about the new usage of XBRL data with the new technologies. Any question or comment? Okay. He
End
just
of a long
mentioned,
day. End of a long day.
And just he mentioned the uniqueness of XBRL, so separation of the metadata and the data body causes these kind of issues for the quick use of the data and so on. Okay, I have one question. Okay, currently in the financial society, anti-money laundering or CFT, countering of terrorism, okay, are they a big issue? Do you think any idea to use this operational database system for such a kind of the detections and so on? Can I have your opinion on that?
I'm not a banker, Wada-san, in any sense. I'm more of a technician. But I would have thought this is something that, you know, you've got to build analytical models to understand where it's coming from. And in fact, it's probably one of those cases where I would propose AI, you know, to be able to look for connections between data between money laundering. Yeah, you can prove this company is money laundered. You can run it through a machine learning task and identify what are the characteristics of those companies doing money laundering. Something similar happened in the UK with their XBRL database. They found the traditional, you know, the people who weren't paying their taxes were the builders, the self-employed. Now, we all kind of knew that, but it's nice to be able to see it as a fact and prove what other factors are influencing. So I think the same thing would happen with money laundering, yeah. You'd find those factors using machine learning sets, yeah.
Thank you very much. Any other questions or comments? Okay. If the traceability of the transaction can be improved, maybe that is a nightmare for money launderers or the terrorists because their transaction can be easily detected. So in that sense, they are not going to use blockchain because in the blockchain, all the transaction record is recorded. So that is not good for money laundering.
Again, well, that comes outside my comfort zone.
And now, just for information sharing, XBRL can play an important role or such a kind of crime detection and so on. So thank you so much. And if there is no more questions, I'd like to say thank you for Martin. Okay, thank you.